So among the three location, you have to find out which location is suitable for the given level of demand and all. Like the location selections we covered in the previous lecture, especially indifference point also be applicable in this question also. Potential locations XYZ have the cost structures shown below. The ABC company has a demand of 1,30,000 units of a new product. Three potential locations X, Y, and Z having the following cost structure shown are available. Select which location is to be selected and also identify the volume ranges where each location is suited. So for what level location X is suitable, for what level Y is suitable, for what level Z is suitable, so you have to find out this. So you know that lower fixed cost with higher variable cost will be suitable for low demand. Higher fixed cost with low fixed variable cost will be suitable for high demand. This will be suitable for mid-range. Anyhow, we can find out the indifference point to get the answer comfortably. Let me actually do the sequencing this way. Lowest fixed cost to highest fixed cost sequence. Now you can connect these point between these two has no meaning at all. Okay. Anyhow, we can calculate the indifference point between Z, X and Z also, but anyhow, it has no meaning. Let's start with indifference point between X and Y. Indifference point between X and Y. So usually indifference point is calculated by this way. Difference in fixed cost divided by difference in variable cost per unit basis. In this case, the difference in fixed cost being 3.5 lakhs and 1.5 lakhs, 2 lakhs is in the numerator value. And difference in variable cost is 10 minus 8, 2 rupees. So 1 lakh unit, 1 lakh unit. So from this it is very clear 0 to 99,999 and 1 lakh. At 1 lakh, X and Y both will be suitable. Now the question is, if the demand is less than 1 lakh, whether Y is suitable or X is suitable, how can you determine? Between these two, less than this will be called as low demand. Low demand should be when the demand is low, then the location with fixed cost lower will be suitable. So X will be suitable here. If it is beyond 1 lakh, Y is suitable. Y is suitable. To what extent Y is suitable? Again, we need to do the indifference point between Y and Z also. So indifference point between Y and Z. So here the difference between these two 6 lakhs. The difference between these two 2 rupees. 3 lakhs will be the level where the cost between Y and Z being same. If it is more than 3 lakhs, okay, definitely high demand will be suitable for highest fixed cost with the lowest variable cost. So here Z will have such a combination, so it will be suitable for this range. In between this gap, 1 lakh, 1 to 2 lakhs 99,999, which is suitable. Here X means here Y, here after X, Z means here Y. Okay, Y will be suitable. As currently the company's expected demand being 1,30,000, the 1,30,000 is maybe produced suitably with a lower cost by location Y. So location Y is chosen. Location Y is chosen. Is that clear? Hope now you'll be able to understand this. If it is clear, text me. Now, next illustration, you can guess and try to answer this yourself. There is no such format most probably available in the text. But I have seen similar illustration once in the CMA final earlier, the old syllabus. Maybe somebody may pick the questions from the old syllabus also. So I have incorporated this different type of illustrations also in the location selection. A firm wants to guarantee 1 day delivery time. Okay, if you order, the firm delivers the goods within 1 day. That's what about their commitment to its customers. It had 8 hours working day. In a day, 8 hours. Okay, and avoids overtime. Avoids overtime. They don't work overtime also. Its order processing and loading time is 3 hours, and average delivery time speed is 40 km per hour. So, though we have 8 hours a day, 3 hours may be lost due to what? Processing, order processing and loading. So, we have effectively 5 hours for the travel, our time available for travel. For every kilometer, we can travel 40 kilometers. Okay, every 1 hour, we can travel 40 kilometers. Suggest a strategic location of the warehouse so as to serve its customers effectively. So, as per the guarantees that they have to serve within or deliver within 1 day, they have only 5 hours a day, effectively after adjusting for the processing as well as loading time. Okay, clear? So 5 hours they have. Every hour the travel distance covered could be 40 kilometer. Now if we multiply with this, okay, 200 kilometers. So from the customer's point, the warehouse you set should be within 200 radius. Within 200 radius. If you have the warehouse here, this radius to be 200 kilometer. So automatically what happens if a customer from here orders, definitely in 8 hours time, 3 hours lost and 5 hours we have. For every hour we can travel 40 kilometers or 200 kilometers we can reach. If your customer orders from here, it's pretty simple. We can deliver much ahead of the time also. So the warehouse you have to fix should be, or installed should be almost 200 kilometers radius from the customer's point. Clear? Now let's move on to the next one. Let's move on to the next one. Next one is all about layout, facility layout. Anyhow, madam may cover some theoretical aspects of these chapters to the extent required. Here are there, I just give some briefing about the theory also required for calculations and other part. Okay. Now, plant layout is nothing but you have chosen the location, okay, in landscape. You have chosen this way. This will be your optimum favorable location. You have chosen based on the other methods, probably weighted average method, weighted rating method, or point rating method, BEP method, or the method what we have discussed here. These are the methods we follow, even gravity method. We have chosen this, okay. In this location, I have to build my facilities. This facility will have n number of different workshops, okay. Clear? So workshop may be this way, okay. So almost around 7 or 8 workshops we have. Apart from that, admin block and other things also be there. Now, where I need to have workshop number 1, workshop number 2, workshop number 3, like where do I want to keep? Workshop 1 maybe in case of a lathe. They may need to have for furniture making, okay, especially steel furniture making. They need to have cutting, welding, trimming, even polishing and painting. All these activities are there. Each and every activity will be carried over in some workshops. Now, we need to have this lathe or cutting or polishing. These are the workshops where can we install. That's what about the facility layout. It should be installed in a place in this in a sequence so that it will be very easy to access. That's a logic here. Okay, some important layout. The layout what you fix, no, easy monitoring and cost effective, and all the area could be effectively used. There should not be misused areas. Employee morale improved and quality control can also be improved, and labor force can be improved, and minimization of delays, minimum investment in equipment and better production control, and we need to avoid the bottlenecks, avoidance of unnecessary and costly changes. If we install, if I want to change, then it will be very, very costly, right? What happens in case of house property? uh, Currently vastu is there. After completion of the construction, the vastu will come, and the vastu expert will come and tell, this is not the hall, it should be kitchen. That's all. So changing will be very costly. So you have to avoid doing those things. Sometimes you install, later on, of course, while working only came to know it seems to be good enough, not good enough. So we want to alter. Can we redesign? Yes, of course. The need for redesign maybe because of the current design or layout, the accidents prone also be there, and health hazards and low safety, changes in environmental and legal requirements also be there, and some processes are changed, and some equipments are changed, product design and service design changed, volume of output increased, product mix changed, inefficient operations due to the existing layout. You want to improve that. So introduction of new products where the existing layout may not be suitable because of new product comes in, to avoid the employees low morale. So all these things are also be a point, or forcing us to redesign the layout. In the calculations part, we are going to study redesigning also. Existing design and what could be your overall cost, and if you are redesigning, then what could be the cost? Can I reduce the cost? All these things are going to be studied here. Now, what are the objectives of good plant layout? So I have given all the lists here. The importance of layout could be here, good layout. That's all. So if you understand this one, importance of layout, you just put that here. What are the importance? Cost reduction, efficient utilization. Then what are the objectives? The same. So in your examination, you can write around 5 or 6 points without any trouble. And choices of layout facilities also be there. Okay, so these are the things are there. Especially very often I have seen questions related to principles for plant layout. The principle for plant layout is nothing but again importance, but minimum travel, sequence, usage, compactness, safety and satisfaction, flexibility, minimum investment. That's what about the main principles we have to consider before we install the layout. Anyhow, once I complete the illustration, then you will be able to understand these points without much explanations. So the layouts are having 5 different classifications: process layout, product layout, combination layout, fixed position layout, and group layout. Anyhow, just briefed a small aspects. I now directly go for explaining the illustrations. After that, I'll just go for summarizing this theory part also. With that, layout chapter will be completely over. See, let's start with the question number 1. In question number 1, Mr. X is considering an interchanging department B and C in the present layout. So this is the layout. This is the layout. Okay, clear. Actually, you know, in company, this will look like this one, right? Clear. There should be easy movable path, and even between the workshops also we need to have the paths. Okay, workshop number A, B, C, D, E, F. Clear. So we have 6 departments. You just think over your schools and colleges. 6 classrooms are there. Usually commerce students classrooms are very closer to the principal room, right? Headmaster's room. Always there will be troublesome, right? Immediately the principal will call for a meeting, so that they always keep the commerce students nearby principal room, right? In our college days and school days, we have the classes closer to the school headmaster's room, right? So you are redesigning. So sometimes we may start with one classroom, suddenly sometimes later the classrooms may be shuffled. Happens, no? Some classes were mischievous, students were very mischievous, then immediately that classroom is shifted closer to the administration office, so that the monitoring will be comfortable. The same happens in case of workshops also. Around 6 different workshops are there, right? Here they want to interchange the department B and C. They plan to change this one. Okay, so they want to shift B here and shift C here. Now because of shifting, they want to know whether is there any benefit, cost reduction or travel reduction. Okay, so in the present layout and the handling frequency between the departments are given below. So this is what about the handling frequency. Okay, handling frequency, clear? Now what would be the effect of interchange, assuming that the departments are of the same size? All the departments, all the rooms are same. Okay, workshop number 1 or 2 or department 1 and 2 being the same size. Okay, also assume that the material handling cost per unit length travel between department is same. Is that okay? What happens, you know, you have to travel between the departments, right? From D to F. Almost the travel between D to F happens almost 100 times in a period. Clear? But the travel between A to F, you know, happens almost 80 times. 80 times. Okay. Naturally, what happens? D to F, more travel is there. Once the goods were finished, from D it may be transferred to F. Is that okay? From F to D also, very often the transactions are happening. Suppose A to F almost 180 times are transported. 180 times are transported. Now what happens? The length of every room may be around 50 meters. 50 meters. 50 meters, right? 50 meters. Assume so. 50 by 50. As it's a workshop, big space required. So almost 50 meter by 50 meter is the size. Now if you want to transport the goods from D to F, the distance between this one is 50 into what's the tonnage we transport? 100. Almost 5,000 tons are transported, like. And in case of this is the transport between D to F and vice versa. What happens in case of A to F? A to F. You cannot go cross, you just shift here, here and here. Almost 3 times you have to travel, 3 times. For every time it's 50. 3 into 50, 150 meters to be traveled. And weight carried being 180, weight or number of travels we do may be 180. Come on, tell me. 27,000. Overall, your travel distance being around 32,000 times. So this is what about the distance. This is what about the frequency. Okay, this is frequency. Okay. And if we multiply these two, that's what about the load and distance. We may assume this being the load. Okay. Either this may be frequency or it may be named as load. You can either say you have to travel almost 180 times in the given period. Here to there, there to here, almost 180 times. Or you have to carry 180 kgs. That way also you can think. Bulk carrying work is there between A to F. So as bulk is very high, 180 tons to be carried forward from A to F, you can make A and F closer. If I make A and F closer, what happens here now? Just see I put the A here and put the D here. So what happens now? A to F distance being only one time of 50 meter. Quantity transported or number of times traveled being 180, then 9,000. Between D to F, 3 times distance is there. Per time distance 50 and frequency of travel being 100. Then what's the value? 15,000. Now what about the overall value transported here? 24. C reduced. You're reduced. From 32,000 times of travel is now minimized to 24,000. Assume that for every time of travel it costs us 10 rupees. Every time if you are traveling one distance means 50 meter with one load or once it costs us say 10 rupees, then naturally it becomes 2 lakhs 40, this becomes 3 lakhs 20,000 rupees. We now omit the cost because if we are able to reduce the distance and load travel, then automatically cost will also be reduced. No, so we never bother about the cost transported here. So load distance cost matrix. Load distance cost. Here the load is otherwise named as frequency. Either it may be load or frequency. Load means that you may carry 100 kgs and instead of load 100 times you have to travel, both may be same. So load, distance and cost. Usually we never bother about the cost remains same. So cost per unit length travel between the department is same. That's how you can assume. So that's why never mind about the C. If I'm able to reduce the load and distance or load and frequency, naturally that will be improved solution, improved one. Now the frequency between A to B being 20 times, A to C being 70 times, A to D being 0 times, A to E being 40 times, A to F being 0 times. Is that okay? So now come on, tell me. We'll start with one distance to another, A to B, A to C, A to D, A to E, A to F. From A to E, different departments, we have 5 options. Now what happens to B? B to C. Why not B to A? B to A is otherwise A to B only. So A to B's distance or frequency is added with the distance or frequency between B to A. What is the distance from Trichy to Chennai? Maybe 330 kilometers. Then what about the distance from Chennai to Trichy? The same 330. You can simply say that as 660. So Trichy to Chennai 660, one round trip. So what is the distance for a one round trip from Trichy to Chennai? 660. Chennai to Trichy also the same 660. So it's already clubbed. You no need to do again this way. B to C, B to D, B to E, B to F. After B, what happens now? We have to start with C. C to D, C to E, C to F. Then we start with D, D to E, D to F. Then finally E to F. These are the travels are there. Now come on. What are the things are needed here? We need to know the frequency. Frequency or load. Load or frequency. Distance we will calculate later on. The frequency or load is given here. Okay. A to B being 20 times. A to C 70. A to D 0. A to E 40 and A to F 0. So you can eliminate A to D and A to F also without you no need to show that one at all. Okay, those things not required to be shown. Similarly, B to C 50, B to D 200, B to E dash, B to F 10, C to D 30, C to E 120, C to F 40, D to E 50, okay, D to F 220, E to F 30. Is that clear? Now come on. What is the distance? Distance between A to B. This will be considered as one distance, one unit of distance. Now, one unit may be 50 or 10 depending upon the size of the department. So I will just consider this being one distance. A to B, one distance. A to C, one distance. A to D, you cannot go cross. So what you have to do? 1, 2. That's how you can name it. 2 distance. A to E, 2 distance. A to F, 1, 2, 3, 3 distance. So I am going to mark the distance. A to B, 1 distance. A to C, 1 distance. A to D, not required. A to E, 2 distance. A to F, not required. B to C, 2 distance. B to D, 1 distance. B to E, not required. B to F, 2 distance. C to D, 1 distance. And C to E, 1 distance. And C to F, 1 to 2 distance. You cannot go cross. Okay. D to E, 2 distance. And D to F, 1 distance. E to F, 1 distance. Now find out the load distance for the present layout. This is present layout. Yes, 20, 70, dash 80, dash 100, 200, dash 20, 30, 120, 80, 100, 220, 30. Come on, get me the total value. Hmm? 1070. 1070 is the current load distance. This is what about the current load distance. Cost not a matter. Cost not a matter. Okay. Now, what is the recommended solution here? They want to shift B and C. Okay. The new one in this case being B and C are going to be changed. Okay. A, C, B, D, E, F. Load remains same, only distances change. So you have to find out the distance for the proposed layout. Proposed. Tell me, A to B, 1 distance. A to C, 1 distance. A to D, not required. A to E, 2 distance. A to F, not required. B to C, 2 distance. And B to D, 1 distance. And B to E, not required. B to F, 2 distance. And C to D, 1 distance. And C to E, 3 distance. C to F, 2 distance. And D to E, 2 distance. And D to F, 1 distance. And E to F also 1 distance. Now find out the load distance based on the proposed plan. Load is this one and distance under proposed model is this one. So you multiply these two columns. 20 into 1, 20. 70 into 1, 70. Dash 80. Dash 100. 200. Dash here 20, here 30, here 360, here 80, 100, 220 and 30. Come on, get me the total now. 1310. Because of altering the layout, we are not actually reducing the load distance, we increasing. So this model is not recommended. We have to recommend to continue with the existing layout itself. Okay, clear? Existing layout is superior. If it is clear, text me. So we'll move on to the next one. Now, question number 2. A defense contractor is evaluating its machine shop's current process layout. The figure below shows the current layout, and then the table shows a trip matrix, frequency matrix, or trip matrix, or load matrix. By whatever the name may be, the calculation part will be the same. Health and safety regulations require departments E and F remain at the current position. So we cannot alter the positions of E and F. Now you have to recommend the alternate solutions. Okay. Can layout be improved? That's a question. Also evaluate using load distance score. Load, distance, and cost. Cost is not a matter, it's only load and distance. Let's see. This is what about the load matrix given A to B. A to B. What is the load here? 8. A to C, 3. Then A to E, 9. A to F, 5. And similarly B to D, 3. C to E, 8. And C to F, 9. D to F, 3. D to E to F, 3. Distance current. What about the current distance? A to B. A to B. 2 distance. Am I right? 2 distance. A to C. 1 distance. A to E. 1 distance. A to E. 1 distance. A to F. 1, 2, 3. 3 distance. Similarly, B to D, two distance, you cannot go cross. This is not allowed. 1, 2, that's how you can show. C to E, two distance, C to F, two distance, D to F, two distance, and E to F, two distance. And find out the load distance for the present layout. This is present layout. 8 into 2, 16, 3, 9, 15, 6, 16, 18, 6, 6. Get me the total load distance for the current layout. 95. They have asked to recommend some other altered or alternate layout also. To suggest the alternate or changing the layout, you can imagine this way. You may have few options also here. You may have few options also here. Is that okay? We'll start here. We'll start here. E and F cannot be altered. So fix it static in the new layout also. Static place in the new layout also. E and F. And now understand that the load between A to the other department, where it is very closer. A to B, the A to E, the load is higher. Similarly, A to B also load is higher. From this very clear, A should be closer to B and D, point number 1. Similarly, the higher number goes to C and D. So from this, C should be closer to E and F. C should be closer to E and F. That's how if you plan, you can easily find the solution. So A should be closer to E and C should be closer to EF. So already EF is here. Closer to EF means you have to post that C here. Okay, you can post it. A should be closer to B and E. Already E is here. Okay, already E is here. Put A here and B here. So now A to E distance also 1, A to B distance also 1. If you put this way, then automatically struggle. Okay, so A to E becomes 2 distance like so. A should be here and B should be here. So A, B, C, D leftover can be posted here, no other way. Clear? This is what about the recommended new layout? New layout number 1. Okay, this one is more than enough, I think. Other alternates may be not worth. Find out the distance for the new layout. A to B, 1 distance. Okay, A to C. Okay, yeah, DTF 1, good. So A to C, 2, A to E, 1, A to F, A to F, 2, 1, A to F, 3, B to D, 1, C to E, 1, C to F, 1, D to F, 1, E to F, 2. Find out the load distance as per your new one. So load and distance to be multiplied. So 8, 6, 9, 5 into 3, 15, 3, 8, 9, 3 and 6. Come on, get me the total value. 50, 67. So naturally this will be most suitable than the existing layout. So you can definitely improve the layout by doing this way. Clear? If it is clear, text me. So next question number 3, also similar one. This one was asked in the exam, carrying 6 marks. 6 marks illustration. Okay. Given below is the existing process layout of the factory manufacturing toys. Okay, the following tables gives a trip matrix. Sometimes it may be load matrix, sometimes it may be trip matrix, sometimes it may be frequency matrix, whatever it may be. All the things will be solved using the same logic. Arrive at an improved layout using the load distance matrix, assuming that E and F should remain at their current position. So, like the earlier one, E and F cannot be altered. First, you try to finish off your cost for the existing layout. So, we have A to 3 departments. So, A to C, A to, I may put here, A to C, A to D, A to E, then B to C, B to E, B to F, and C to D, C to E, D to F, D to E to F. Now, what about the load here? Load 2, 2, 1, 1, 6, 5, 1, 4, 5, 1. Start with the distance here. Okay, A to C, distance being 2, A to D, distance being 2, A to E, distance being 1, B to C, 1, B to E, 2, B to F, 2, C to D, 2, C to E, 1, D to F, 1, E to F, 2. Now you can find out the load distance for the existing matrix. Now, 2 into 2, 4, 4, 1, 1, 12, 10, 2, 4, 5, and 2. What is the total now? Is it 45? Hope now we'll be able to get this value. Now I'm going to recommend the improved layout. For the improved layout, okay, new layout. These two cannot be changed. E and F cannot be changed. Now, B here, B to E has higher load value. Otherwise, B should be nearby E and F. So we can put the B here. Okay, E should be closer to E and F. Thereafter, D is having the huge load, phi load between D and F. So you can post the D here, or the existing D is correct, you no need to change. Another one is C should be closer to E. So I can put the C also here. This is also as per the existing one. And only one new change is A and B. This entire departments are shifted. These two departments are shifted. This will be the new layout. Now find out the distance as per the new layout. A to C, 1, A to D, 1, A to E, 2, A to C, 1, B to C, no? B to C, 2, and B to E, 1, B to F, 1, C to D, 2, C to E, 1, D to F, 1, E to F, 2. So now load distance as per the recommended new layout being 2 into 1, 2, 2, 2, 2, 6, 5, 2, 4, 5 and 2. What's the total value? 32. So the new layout is now recommended here. New layout is recommended. Shall I move on to the next one? Some basic theories here. Let me first finish off classification of layouts. We have process layout, product layout, combination layout and fixed position layout and group layout, otherwise named as cellular manufacturing layout. The combination layout is otherwise named as hybrid, fixed position layout otherwise named as static layout. In process layout, all the machines carrying similar job will be kept in same department. Okay, same department. Okay, for example, lathe, milling. Similarly, we have welding, grinding. These are the machines. Okay, so lathe. If we have 2 or 3 lathes, all the 2 or 3 lathes will be kept in the same department. Milling machines will be kept in the other department. Like, if you want to manufacture any product where it requires lathe operations, milling operation, grinding operation, then that product is taken to the lathe first. Lathe work is done, and then it will go to the milling, and then later it will go to the grinding department. Department wise, it may be transported. The finished goods transported, the raw materials transported, and finally it comes as output. See, milling machine. This one is the department. Welding, grinding, inspection, lathe, assembly, painting, finally shipping. Such a way, similar process items are grouped in one department, department 1 and department, not necessarily the same size. So we have seen for the example, all the departments will be equal size, but not necessary. Here, see, lathe has a larger space and assembly also. Right. If I want to manufacture, say, this is all about an engineering department or workshops like. I may suppose to manufacture a machine. Okay, for a company, probably some machines are going to be manufactured. For that machine, I need the first milling and then welding. After the finishing the welding, I need to do slight grinding to remove the sharp edges and finish whether it is correctly done or not, inspection, some lathe work. So the material we put here will pass on through one department to the other department. Finally, it comes out as a finished goods. So every department will have similar nature of activities. If we are grouping all the similar nature of items in one department, then it is called process layout. All machines performing similar type of operations are grouped at one location, like lathe, milling, etc., grouped in the shop. Okay, this process layout is recommended for batch production, usually batch production. Okay, batch of production, products are manufactured, then it will naturally go this way, this way, this way, this way, and it comes out. So each and every product or a batch of product is introduced here. It will pass on through all these things and comes out as a output. This is called process layout. The advantages of this process layout being machines are better utilized. Okay, and fewer machines are required. Fewer machines are required. For example, if I want to manufacture a furniture mart, okay, furniture manufacturer, chair, table, and shelf, or some other customized product. For manufacturing, even bureau. For manufacturing table, if they have a small workshop, what are the things are required? Cutting of the steel and welding, grinding, and inspection and polishing, painting. All these machines are required for table alone. For chair making, they need to have all the set. And for shelf as well as for bureau and customized material, we need to have all these machines, right? If I'm keeping a particular department with all the machines required for manufacturing one output, then it's called product layout. This is called product layout. This will be one department. This will be one department. In this department, all the things are available one after one: turning, milling, drilling, assembly, inspection, packaging department, dispatch. This is for table. This is for table. Similarly, I need to have for workshop, means for manufacturing the bureau, I need to have the another set. Machines are located according to the processing sequence of the product. First, what is the work you have to carry on? Turning, thereafter milling, thereafter drilling, thereafter assembly, then inspection and packing and dispatch. So machines are assembled in the processing sequence itself. If the volume of productions of one or more products is large, here we have one or two products only one or two products. Okay, only tables are. I need to have table as well as I need to manufacture bureau and I need to manufacture some other customized material. I cannot have similar items for all these products to be manufactured. Then we can go for the process layout. But in case only one material, I'm going to manufacture the n number of times or in large quantity, then the product layout will be suitable, where the machines are arranged as per their processing sequence. Okay, so achieve efficient flow of materials and lower the cost per unit will be possible because of the product layout. Hope you will be now able to understand process layout as well as product layout. Now, what about the mixed or combination layout, sir? Okay, see, in process layout, what happens? Process layout, similar machines are grouped. Similar, okay. Similar machines are grouped, okay. Layout. In case of product layout, okay, sequence as per the process. Now, if you think this way, this is forging hammer. F represents forging hammer. H represents heat hobbing machines. HT represents heat treatment furnace. GF represents gear finishing machines. Okay, this will be a process layout. Is that clear? Because in this particular department, this particular group will be for forging hammer only. All the forging hammers are assembled here, are available in this particular department. If you see the department this way, what happens here? A product is introduced as input here, forging and hobbing, heat treatment, gear finishing, and comes as output. So if you see in horizontal sequence, then it is called product layout. Vertical sequence, then it is called process layout. The entire means workshop layout, department layout is designed in this way, then it's called combination layout or mixed layout. A combination of process and product layout combines the advantage of both types of layout. So every layout has its own plus and minus. By doing the combination of these two, you will have combined benefit, right? So because of process layout, we have some disadvantages, as well as product layout, we have some disadvantages. Both are going to be removed because of the combination layout. Clear? Third layout. Then let's move on to the static layout or fixed position layout. Here, the finished goods remains the same place. The machines required for manufacturing the finished goods will come here. Material, machine 1, machine 2, and labor force. Everything will be shifted to the place where the finished goods are manufactured. Especially, shipbuilding will fall under this. We cannot build the ship in some outskirts and transport that to the ship, means to the ocean or river. It's not advisable, right? So very huge. So that ship and other things are ship, whatever it may be, built nearby the ocean or sea, and from there immediately it is transported to the or remote, remote to, means taken to ocean. So for the shipbuilding yard, it remains the finished goods place will be the same. Material will come here, labor will come here, equipment will come here, and finished product being the ship is then landed in the ocean or sea. Is that clear? The material or major components remain in fixed location, and tools, machinery, men, and other materials are brought to this location. This type of layout is suitable when heavy products are to be manufactured like ship, okay, and when assembly costs of large number of heavy parts, the cost of transportation of these parts is very high, okay. In this case, fixed position layout or static layout will be suitable. Example in this case being shipbuilding. Clear? Shipbuilding. So you can go through the advantage also. Now, group technology layout, cellular layout. This one is a modern current what departmental stores like Geomart and some other D-Mart, like, right. So where everything is assembled, what you can do? So in D-Mart or any supermarket, if you go inside, whatever the things you want, you go and buy and go and buy and go and buy and come here and go here. You are feel free to go here or there to buy what you want. Similarly, in group technology layout, whatever the products required to be manufactured, what are the processes needed to be carried over, take the raw material here. The processor needed maybe W, Y process, Z process, and may come out. Okay. So the raw material is converted into finished goods by passing these three workshops alone. Or sometimes the raw material may be transported to here, and will come out as a output. So you have the flexibility to go and use any of the processes also in the machines available there. For example, W and Y. This is mill. Number 1 is mill, drill, shoulder, grind, and polish. So 5 departments are there. 5 departments are there. Is that okay? Now, what happens? If I want to manufacture W, what happens here? I need this service, and this service, and comes out as an output. So the W requires only 3 processes: milling, drilling, and polishing. Milling, drilling, and polishing. That's all. Instead of that, if I want to manufacture X, what happens then? X requires drilling and shoulder and comes out. Right. Whatever the things you need, just recollect this with the normal supermarket. Like you go and based on the stalls where you want to go, you go and purchase and come back. There is a trend now to bring an element of flexibility into manufacturing system as regards to variations in batch sizes and sequence of operations. Batch size also different and sequence of operation also different. A grouping of equipment for performance sequence of operations or family of similar components or products has become the important. So here a family of milling, family of drilling machines, family of soldering machine, and family of grinding and family of polishing machines are installed here. C, GT. GT can be, okay, group technology layout can be used to develop a hybrid between pure process layout and pure flow line product layout. For process as well as product layout, the hybrid system like only, but it's much advanced one. This layout is very useful for companies that produce variety of parts in small batches to enable them to take the advantage of economies of flow line, varieties of products to be manufactured, then we need to have this. So from this it is very clear, in case of product layout, number of varieties will be lesser. In case of process layout, varieties are higher. Okay. Yeah, of course, the process layout has some advantages as well as limitations, and product layout also has some advantages and limitations. To remove the limitations of process and product layout, we can have the combined one, even still improved version being the cellular layout or group technology layout. Hope you will be now able to understand this one. Clear? So with that, layout chapter is completely over. Location and layout chapters are over. If you have any doubt, you can ask me, else we'll move on to the next chapter. Resource aggregate planning, or in short, we can call this being aggregate planning. Aggregate is nothing but summing up, grouping, meaning the production planning of the quantity and the timing of output. Okay, usually it's nothing but planning of your production, how many units you have to produce, within what time you have to produce. All these things are going to be analyzed here. The resource aggregate planning is usually called as intermediate range planning, anywhere between 3 to 18 months. If you project for a plan or budget or production plan less than 3 months, then it is usually called a short term plan. And if it is more than 15 months, then it is called long term projects, where we may have the forecasting as well as the budgeting and all. But if it is anywhere between 3 months to 15 months, there's a gap, for that this aggregate planning, this is called mid-range, mid-term planning. For this aggregate planning is used. In aggregate, what we mean is nothing but gross production of homogeneous goods. That's called aggregate planning. Gross production of homogeneous goods. Probably, if you take Asian Paints, okay, they predicted what could be the paint requirement. Maybe they are in need of, say, white color, red color, green color, and yellow. They have a number of shades, right? So this may be, say, around 1 lakh liters, like this may be around 5 lakhs liter, this may be around 6 lakhs liter, this may be around 7 lakhs liter, like. So now they will be aggregating all these things just like paint. What about the total paint requirement? Okay, 17, 14, 19, or I can make it to 20 lakhs liters or 20 lakhs liters of paint required in matter of 3 or 4 months. They have calculated this. Only the pigment, the color is different, right? So the final color will be adjusted later on. Now they plan for producing 20 liters of paint. It is not what color it is. This called, it's only paint. No, all these things are variant of colors. Anyhow, it's a homogeneous goods only. The basic ingredients being the same. Basic ingredients being the same. Is that okay? Now, gross production, 20 lakhs is considered as aggregate. Similarly, in case of Maruti car, they may have around 10 to 20 different varieties of cars. Okay, all these 20 or 10 to 20 varieties of cars are going to be grouped into small car, like one brand car, like, okay, K10 and Shift Desire and Desire, so Baleno, and they have so many varieties. They consider the K10 being the basic model. Shift model will be equated to 1.25 times of the K10 model, like, and Shift Desire will be 2 times of this one. Desire maybe 2 times or 2.25 times, like. If they need to manufacture 100 K10 cars, then it is 100 cars. In case of Shift, 100 means it is equated to 125 K10 cars, like. They just making in small, means gross production, like. So now they will estimate 100, this may be 50, this may be 100, this may be 200, then 100 into 10, 100, 50 into 125, probably make it 60, so 75, 100 into 2, 200, and 200 into 2.2, 4.440. this much of K10 supposed to be manufactured. Then what is the material requirement, like steel and other component, engine requirement? All these things are calculated based on the aggregate grouped production here. So hope you will be now able to understand this is the a prediction or planning for the intermediate range, and it's a link between short term and long term planning. Aggregate is nothing but concerned with the gross production of homogeneous goods. Homogeneous goods. Plan of production by adjusting. How can we plan, sir? See, I need to manufacture around 125 units every month based on the predicted demand for 18 months on average. But my production capacity is only 100 units, sir. Okay, per month. This is what about the demand estimated, forecasted. This is what about the capacity I have. How can I manage this? So I can manage this way. What? I can have already create a stock for the shortages. Okay, ahead of the incoming days demand, I can have 25 units being the stock, or I can recruit new employees to produce more, or I can ask them to work overtime so that production rate may be increased. Okay, or other reasons. Somehow we have to develop our capacity to match with the demand. Okay, so plan of production by adjusting production rate, inventory, employment, or any other controllable variables. If we have all these things are factors we have to adjust our capacity to match with the demand forecasted. But if you do so, what happens here? If I keep the stock, then we have to spend the carrying cost for the stock, employment, recruitment cost, and after the usage, we no need to have the employees. We can terminate them. Hire and fire will be their reason, and overtime. Then overtime wages will be there, and we can go for the subcontract and whatever the mode may be. So for the shortage 25, we can go for the subcontract all. So in case of subcontract, they will demand more cost per unit of production. So these are the costs involving. You have some means chances to improve your capacity or to match your capacity to the demand required, but it has some costs. Now, among these alternatives, you have to decide which alternative will be best by reducing cost as well as the company's image should also be not damaged. That's the logic. So, three predominant strategies we have. One is chase demand strategy, level production strategy, another third one being stable workforce strategy. We have three strategies. Chase demand strategy means whatever the demand we forecasted in the coming days, I produce as per the demand forecasted, then it's called chase demand strategy. Level production strategy, the next month I'm in need of 150 units. Thereafter, I need to produce only 100. Thereafter, I need to produce 250 units. 250 units. Okay. Then another 100 units. What can I do? Add up all these values. I am in need of 600 units to be produced in 4-month period. I constantly produce 150 every month. This is called level production strategy. Okay. When I produce more than the requirement, I keep the stock. When I produce less than the units required, then I use the stock to pay or use for supply. 250 needed, but 150 produced. Already stock I have 50. So 200 I have, but demand is 250. The shortage of demand 50, you ask the customers to collect in the next month. In the next month, I produce 150, supply 100 here, and here this customers not served, he will come and collect. So here minus 50, this fellow is now happily accepts this month. This is called stock out, okay, or belated supply. But sometimes no, the customers will not accept, sir, I need this time only. Tomorrow I don't want. So I'm coming for the lunch. Don't ask me to go for dinner. I'm feeling very hungry for the lunch only. I cannot sustain my hungriness up to the dinner to have discounted food, right? How can I have the lunch and dinner at dinner? So it's not possible. So then there may be losses. This is called level production strategy. Level production strategy. Another one is stable workforce. Another one is stable workforce. What is that, sir? I have 5 employees. I retain the 5 employees. Each and every employee is capable of producing 30 units. So 150 I will produce. 150 I will produce. Is that okay? But when the demand is higher and matching, no problem. When the demand is lesser, I'll ask the employees work leisurely, and I ask them to leave faster. So there may be idle time for the 50 units. When the demand is higher, I ask them to work for overtime. So because of this reason, we maintain the stable workforce. When the demand is more, we ask them work more by seeing the overtime. Then we need to spend overtime wages. When the demand is less than our capacity to manufacture, we ask the employees to retain or just be idle. So though they are idle, we have to pay the salary. So that cost will be involving in case of stable workforce. Chase demand strategy is nothing but whatever the demand is there, I have to match that. Okay. So my intention is I have to match with this production. So my demand is this one. My production is also 150, 100, 250, 100. How this is possible? To chase the demand. So maybe, so when the demand is lesser, I can fire the employees. When the demand is higher, I can hire the employees. Hire and fire strategy. Or when the huge demand is there, to the extent I can manufacture. Shortage, I can relay about the subcontract also to the third party also possible. Hope you will be now able to understand this one. Is that clear? Chase demand strategy, level production strategy, and stable workforce strategy. So these are the 3 strategies we have. Okay. Now, what about the decision variable you have? Like, as per these strategies, you know, what are the decision variables you have? See here. Chase demand strategy. Vary production to match demand by changing the employment. When higher demand is there, we can recruit additional employees. When the demand is lesser, we can send out employees out. Varying size of workforce, and which is nothing but hiring and firing. While hiring, we have to spend the hiring cost as well as the training cost. While sending them out, we have to pay the retirement benefits layoff cost. So if I plan, can I change the workforce? Then it has associated costs. Or I can use the overtime or accepting idle time. Just now I told you. I constantly produce. When the demand is higher, then I ask the employees work more in the overtime after the working hours. Then we pay extra overtime premium. When the demand is lesser, we ask the employees to work leisurely, take idle time also. So then we have to pay for the non-productive time also. That will be cost. And we can change the inventory. I already told you, no. When the demand is lesser, we produce more and keep this inventory held with our godown. And later on, when the demand is higher, we will supply from the godown. So carrying and storage cost will be there. And sometimes accepting the back order. Sir, this month they cannot supply. Next month you can take. Okay, if I say for 100 units, okay, so 100 units I cannot supply in this month, you can take in the next month. Customers may be willing to take up around only 40, but others may reject. Few customers may accept, okay, sir, I will come in the next month, and most of the customers will neglect our options. If they don't take our options, then there will be stock out cost due to the lost orders. We lost the orders, right? And constantly we produce an extra requirement, you can simply go for subcontracting that. If you go for the subcontracting, the price they demand will be usually higher than the cost we spend for manufacturing ourselves. So higher labor and material cost. And you can change the capacity also. But capacity means installing new machines and all, but it's really costly. Okay, it's not suitable for the short tenure. Delayed response, and higher fixed costs. So we have 3 strategies to match with the predicted demand in the coming days. Either it may be chase demand and level production and stable workforce. Among the 3 strategies, to match our strategies, we have these are the variables to alter. If we choose one of these alternatives, then we have to incur these costs also. Hope you will be now able to understand. So aggregate planning is nothing but group the production, forecast the production. This is anywhere between 3 months to 18 months, like, okay, 18 months or 15 months. Third, apply the strategy, and as per your strategy, what you have to do, decision variable. Okay, what do you do? Are you going to work overtime, or are you going to give it to subcontract, or are you going to hold produced higher and in your go down stock? Based on that, you have the cost. You have n number of models in practical life. No, usually these details are fed into the computer will generate a good solution. You have thousands of models also in practical life, but in your examination you are going to apply one or two models only. And if you use one or two models, one, two, three, what you can change higher and fire model, or you can produce and keep in stock so that higher demand may be met using the stock, or you can ask the employees to work overtime, or you can subcontract for the excess demand, or you can produce as per your standard number of units produced with excess demand. You say, I don't want to take up. Whatever the decision you take, and it has a cost. Now, as per the cost, the lowest will be chosen among the various costers, or the cost you found out for the various decisions variable you have implemented. The lowest cost will be chosen item here. Clear? Let's start with the first illustration. I am going to guide all these things. Here, question number 1 onwards, only discussion problem. You don't need to panic with that. In your examination, 1, 2, 3, 4, 5, up to 5, all these things are understanding illustrations, not required for your examination. Especially question number 6, mixed strategy, may be applicable in your examination. 6, 7, 8. 6, 7, 8 for the examination purpose. First 5 are for the understanding purpose only. I just explain. Okay. This is not absolute question, so I assume now and then to solve this illustration. Right. So 6, 7, 8 are the most important exam based questions. Of course, I think I have already solved the book back problems available as a video form. You can go and watch that also. Right. Now let's start with this. Here, what strategy is going to be followed? Chase demand strategy. 3 strategies are there. One of the strategies being chase demand strategy. For that, what decision variable I am going to do? Varying the workforce. Varying the workforce means hire and fire. Hire and fire. Okay. A company has estimated its quarterly demand as shown below and wishes to restore ending inventory and employment, etc., to the beginning level accordingly. So whatever the inventory, employment, they have no number of employees they have at the very beginning. They have to maintain the same number of employees in the end also. Okay. Each quarterly change of 200 units of output has an incremental labor cost of rupees 2000, and ending level must be restored to the initial levels of 2 employees. Initially we have 2 employees. At the 4th quarter end also we need to have 2 employees only. For every 1 employee, we are able to produce 200 units extra, but for that we need to spend 2000 rupees. That's what about the details, right? Okay, for each quarterly change of 200 units. Okay, so we need to spend 2000 rupees for 1 new employee. Okay, see here 500. Currently we have how many employees? 2 employees. 2 employees means per employee can produce 200 units, means 400 can be produced. But in the very first case, I need 500 units. Then how many number of employees I may need? 3 employees. In case of 900, I am in need of 5 employees. In case of 7, I need how many employees? 4 employees. In case of 300, I need to have only 2 employees more than enough for every employee. Sir, don't ask me how do you get this one all. So how can you decide that, sir? I just assume myself. 200 units of output can be produced for an incremental, means the incremental laborer, one in laborer. That's how I assume. Currently we have how many employees? 2 employees. But because of the first quarter's excess demand, I recruited 1 extra. Again here I recruited another 2 extra compared to the first quarter. Then I sent 1 employee out, and then I terminated another 2 employees out in the 4th quarter. Is that okay? So in and out. For every situation, right? 3 additional recruitment, 3 termination. Whether you recruit or terminate, for every employee it costs me 2000. Sometimes hiring cost may be 2000, termination cost may be 3000 or 1500. The number may be different also. Here clearly stated that incremental labor cost for changing, either it may be addition or deletion, whatever it may be. In both the cases, the value being same 2000 rupees. So the value here being 6000 and here also 6000, overall value being 12,000 rupees. 12,000 rupees. Clear? Now, come on, tell me. Come on, tell me. 12,000 rupees. Because of applying the chase demand strategy by changing the employees, now we are able to match the demand of market. What happens for the employees' morale? If you are being the employee in this company, will you be happy? This month you will get the job, next month you will be chased out. Will you be happy? So the hire and fire, though it may be cheaper, but it of course it spoils the image of the company among the employees market. So thereafter you don't get the quality employees also. That may also be a trouble you face. So as I already told you, while applying the strategy, not only the cost matters, sometimes you have to consider the other factors. The company's image also matters, right? Hope now you'll be able to understand chase demand strategy by using the varying workforce model. If it is clear, text me. So, again, second scenario, chase demand only. My strategy is chase demand. Chase demand means I produce only to the extent demanded in the market. But rather than hiring and firing, I maintain stable workforce strategy. Okay. So stable number of employees I'll maintain. If there is any additional work required, I'll ask the employees to work overtime. If the job is lesser, then I'll keep the employees idle without any job. Okay. So what happens here? This is a scenario. Maintain a stable workforce capable of producing 600 units per quarter and use overtime at 5 rupees per unit and idle time at rupees 20 per unit. So now find out whether overtime is required or idle time is lost. If the demand is 500, I am capable of producing 600 means I cannot ask the employees to work for 100 hours or 100 hours or 100 units production capacity remains wasted or idle. Remains idle. 900 means current employees capable of producing 600 units. Because of 900, I ask them to work in the late hours, overtime. And 700 also we ask them to work in the late hours, 100. 300 we have to keep the employees idle, but we have to pay. Overall overtime being the work done by overtime being 400. 400 units production capacity remains without any production. For overtime, I need to spend rupees 5 per units of produced in the overtime, means 2000 rupees. And in this case, for without work, if I'm paying the salary, it costs me 8,000 rupees. 400 hours, 400 units production capacity remains unutilized. For every hour, I have to pay 20 rupees, means 8,000 rupees will be my cost. Come on, now if you add up these two, overall cost in this case being 10,000. Come on, tell me, between these two strategy, which is better? This is also chase demand, this is also chase demand. But here, cost is also higher and fire rules will not have actually creates good image to the company. So between these two, this strategy seems to be superior. This strategy seems to be superior. As well as I used not only chase demand, stable workforce also clubbed here. Clear? Clear? Shall I move on to the next one? Now we'll move on to the next one. I may now go for the level production and stable workforce strategy, where I plan to change the inventory levels. Okay, level production strategy and stable force. For that, I change the inventory. Okay, this one, varying inventory level. The same illustration. Okay. Now, vary inventory level but maintain stable workforce producing at an average requirement rate. So, what is the total requirement over 4 quarters? 2400. So, divide that by 4. So, 600 to be produced every quarter. Like, what about the quarterly production? Quarterly production 600. So you maintain the stable workforce to produce 600 units only. Is that okay? With no overtime or no idle time. So we don't have the overtime or no idle time. We ask the employees work round the clock as per the regular stream. Come by 9 o'clock and leave by 5 o'clock. That's all. We never torture the employees like earlier one. Earlier case, no, when the work is heavier, we ask them to work in the late hours also. Here it's not so. Employees can also plan their life as per the schedule we gave them for working. Carrying cost based on the average inventory is 32 per unit per year, and firm can arrange to have whatever the inventory level is required before the period 1 at no additional cost. And storage cost based on the maximum inventory is 5 rupees. So carrying cost as well as storage cost. Carrying cost is nothing but the cost you spend for carrying it for a longer period. Okay. Here storage cost is nothing but storeroom price or rental for the storeroom. Okay. If you want to have only one unit to be stored, okay, it costs us 100 rupees. For 100 rupees, you have to borrow and invest here to buy this commodity and keep this for a 1 month period. For that, if you say 1% will be your cost interest, then 1 rupee you have to spend. If you want to store 100 units, 100 into 100, 10,000 rupees you have to invest. Okay, for this is 1 unit for 100 units. If you want to store 100 units, you need to have 10,000 rupees. If you borrow 10,000 rupees, 1% interest you have to pay per month means you have to pay 100 rupees. Am I right? But what about the storeroom you need to have, warehouse capacity? Sometimes you may be storing only 1 unit at the maximum, sometimes it will be 100 units also. Come on, tell me, what could be the storage size you need to take in rental? 1 unit or 100 unit? Can you ask the landlord, sir, today I am going to store only 1 unit, sir, give me small space. So next month I am in need of 100 units, give me 100 units storage capacity, storage place. It's not possible. So sometimes I have only 4 or 5 students only in my class. Sometimes I may have full capacity. Now, if I ask my landlord, sir, I need the classroom size only for accommodating 5 students. Take the rent as per the 5 students capacity. Suddenly I may be in need of 50 students capacity. By the time I pay extra rent, which is not really possible, right? So then what could be my classroom size? My classroom size should be equivalent to accommodating the higher number of students possible for any subject. Is that okay? So naturally what happens now? I have to keep the capacity for 100. This is what about the storeroom price. This is what about the carrying cost. Okay, nicely the question is drafted here. In case of storage space, this is called storage cost. Based on the maximum inventory, you have to create the storage space where per unit cost is 5 rupees. In case of investment based, so investing in the stock to buy and hold, you need to spend around 32 rupees per unit based on the number of units you store. Average unit can be taken. That's one of the beautiful concept given here. You can understand this along with the material costing chapter in your costing paper later on, right? Or you might have studied in your intergroup 1 level. Clear? Quarterly production. Okay. Now what happens now? What about the stock? You produce 600 units, demand is 500, so 100 units being stock. You produce 600 units plus another 100 is stock, 700, but you have to supply how much? 900. There's a stock out of 200. Then you produce 600, you spend this 200 already, 400 you have, but you have to uh, meet the demand of 700 units, so minus 300. Your stock out being 300. And 600 produced, already stock out 300 is now met out of this production. Balance 300 can be used for current year's demand, so 0. Actually, you should not have the stock out scenario. No stock out scenario. No stock out scenario. Then how can I plan the no stock out scenario? What is the maximum stock out as per this calculation? 300. You know, assume you have opening stock is equal to 300 units. Why do I want to assume, sir? Clearly stated here. The firm can arrange to have whatever inventory level is required before the period 1 itself at no additional cost. Whatever the inventory level you need to have in the beginning day itself, by the third period you are going to face negative 300. So in order to avoid that negative 300, in the very beginning itself you can maintain the 300 units. Sir, if I have 300 units in the very beginning, what happens? So for the fourth quarter after, you can sell in the fifth quarter. It's a continuous process. So you are allowed to store the negative, maximum negative stock you have in any period in the day 1 itself. If you have, what about the stock situation now? With this assumption, what is the stock? Okay, the stock being opening stock plus production minus demand or supply. 100 plus 600 plus 300, 900 minus 500, 400. 400 plus 600, 1000 minus 900, 100. 600 plus 100, 700 minus 700, 0. So now you don't have the stock out scenario. 600 produced, 300 supplied, 300 you have the stock. The fourth quarter end stock 300 can be used for the next quarter. Right. What about the total stock you have over this period? Average being 200. Now, what about the carrying cost? Average stock you have into 32 rupees, 6,400. What about the storage cost? Based on the maximum capacity, the maximum requirement being 400 kept in the period 1. Okay. So for every unit, I need 5 rupees for the maximum. So your storeroom capacity is to accommodate 400 units. So naturally for 400 into 5, 2000 rupees. From this it is very clear, 2000 being the storage cost. Okay, storage cost being 2000 rupees in total, 5 rupees per unit for the entire annual storage cost. Okay, annual storage cost. So then ultimate value here being 8400. Among the 3 options what we have discussed here, which seems to be the best option? In this case, what happened? We torture the employee to work higher or overtime whenever the demand is higher, and we keep them idle. So if you ask you to wait for means meeting the doctor, what happens? Or meeting the principal, or if you want to meet somebody else, then the somebody asking you to wait for 2 hours, 3 hours, what happens? Will you be happy or irritated? While booking for a bus ticket or train ticket, you are in queue for 2 to 3 hours. How do you feel? So being idle without job also be tension, and asking you to work also be tension. So before that, hiring and fire is very tension, and this may be moderate to okay, but this seems to be the best options. The cost is very cheaper, 8400 than this one, and also employees also comfortably working. Come by 9 o'clock and leave by 5 o'clock. Every day do the routine of production. No need to work hard and no need to work without any job. No need to be idle without any job. Clear? Third option. Third option. Maybe used in the next quarter, fifth. It's a continuous process. I told you no. The fourth period stock 300 can be used for the next quarter, fifth quarter. We predicted what could be the demand for the 4 quarters. Our business is not ended with that. Thereafter also our business continuing, right? So fourth quarter stock may be used for the upcoming quarters. Now let's move on to the next one. The same illustration. What happens in this case? Accepting back orders and allowing some extent stock out also. Back orders means if the order is in quarter 3, we ask them to get it delivered by fourth quarter. But all the customers will not accept. Some customers may neglect to accept for the delayed one. So we never care about that. So we may stop supplying for the customers who are not accepting our delayed supply. So back orders along with the stock out also. To some extent we can accept. Produce at a steady rate of 500 units per period. So your production being 500 per period. And accept a limited number of back orders when the demand exceeds 500. The stock out cost of lost sales is rupees 20 per unit. Because of you are not able to supply, okay, your demand is now lost. Your customer's demand is lost. If you are losing not to supply, then you will be losing around 20 rupees for every lost supply. Okay. Now what happens? What about the stock out here? Stock out or back order and stock out. Back order and stock out. So first quarter no problem. What the demand is there, now we met with the production. Second quarter 900, but we produced only 500. So you can plan, sir, we can give 200 in the next month, sir. What about another 200? Cannot be supplied at all. This will be stock out. From this it is very clear, definitely stock out should be how much? 400. Stock out should be 400. We are capable of producing only 2000 in the projected period, but the demand is 2400. So definitely 400 units cannot be supplied. In the second quarter, we are in need of 900 units. We produced only 500. So we asked some customers to take it in the next month. Some customers we neglect, sir, we don't have the goods delivered for you. Similarly, in the third month, what happens, you know, out of 700, okay, 300, you know, out of 500, 200, you have to accept for this back order. I told the customers in the second quarter, get in the third quarter. So this fellow will come and ask me, okay, you take this. Now we have only 300 units to be supplied to 700 units. 300, 700, which is not possible. We consider 200 can be delayed supply in the next period. Another 200 can be rejected at all. The next period, 500 produced. This back order is supplied. Balance 300 can be used for meeting this fourth quarter demand. So that's all. Back order, okay, because of the back order delayed supply, 400 units were lost, and for every lost unit, 20 rupees you are going to lose your profit. Around 8,000 will be your loss. Because of this approach, what happens? Customers' reliability is lost. Customers are unhappy. So I came because of your performance, but you just neglected to buy the product from me. So what can I do? 8,000. Is that okay? So among the 4 models, I think the third model seems to be superior. The cost is 8,400. Compared to the third, fourth model, where the cost is 8,000, still customers' loyalty is missing. Our customers know I say I cannot supply to you, then he may approach some other new seller. Automatically next time he will not come, so we are losing the customer's loyalty. Clear? So among the four model, third model may be better. The last one being very simple one. Very simple one. See here. Produce at a steady rate of 300 units per period. Subcontract for excess requirement at a marginal cost of 8. So production being always 300. Always 300. When there is a excess requirement, the minimum requirement in quarter 4 will be produced from us. Whenever the demand is higher, we produce from the outside. Subcontract. So first case, demand is 500, production is 300, 200 subcontract. Next 600, next 400, next dash. Overall subcontract being 1200 multiplied with 8 rupees, 9600 rupees, you are losing the money because of the subcontract. So your capacity remains the same. When the demand is higher, we outsource this. Okay. So earlier it happened in a restaurant. When I prefer a particular dish from a restaurant, usually I'll go there only because of the dish. Suddenly a day I reached by 9:30, I ordered the dish, the taste was totally different. Only then realized they purchased from the local shop and supplied in their own restaurant, stating that it's our product. So the moment I tasted it, then I found that it's not your product. Then what happens? The next time onwards, I stopped going there. So sometimes no, it happens. I produce, then the quality may be different. If I subcontract, the quality may be not up to the mark. Though it may be requires, it may be with the strict control of production, yet there may be slight change. Clear? Hope you will be able to now understand the concept of strategy, means aggregate planning here. Okay, all these things are for understanding purpose. Now here you see. So we have three strategies. How can you plan? Chase demand, level production, stable workforce. For that, what could be your plan? Either you can change the workforce, or ask them to work overtime, or ask them to leave early or be idle, and you can change the inventory, or asking the customers to take it delayed, back order, or excess demand can be subcontracted, or you can use new plant installation, or you can install a new plant also. So for all these things, we have some costs. Among the other models, so 4 or 5 models we found out, among those 4 or 5 models, the cost will be cheaper, as well as it should be good for the company. It should not spoil the company's image. It should not create a panic among the employees, or it should not actually create some loyalty issue with the customers. Then all these things also be a matter here. Clear? So now we'll see exam based or book back problems here. Mixed strategy. Question number 6. We may have 2 or 3 strategies here. Earlier we have seen 5 models now called pure strategy. Pure strategy means we have only one, hire or fire, or inventory model, or subcontract model. Practically we may have all the combinations. Extremely changing the demand. Then we may have hire and fire, some extent inventory, some extent contract, some extent we may lose the order. Everything put together will come as a single problem, which is called mixed strategy. Now, custom furniture company currently has 100 employees and has the forecast quarterly demand as shown in table given below. Quarter, 1, 2, 3, 4. What about the demand? 3,500, 5,000, 4,000, 3,450. Overall demand being 15,950. Okay. Current number of employees they have being 100 employees. The historical average production rate is 40 units per employee per quarter. So 40 units per employee per quarter. 100 employees means 4,000 units can be produced. 4,000 units can be produced. And then the firm has a beginning safety stock inventory of 1,000 rupees. Opening stock already they have 1,000 units. The hiring and training cost being 400 per employee and the layoff cost. Hiring 400 rupees and firing or layoff being 600 rupees. Also, we can carry the inventory at a cost of rupees 8 per unit per quarter. Carrying cost rupees 8 per unit per quarter. Okay. Use the data to develop an aggregate plan that uses the variable employment and inventory to meet the demand. Here you have n number of models possible. As already told you know, we don't have a standard model. We don't have the standard model. Whatever the solution you give now based on your assumptions is acceptable. Okay, no need to panic in your examination. Here I'm going to I assume I have changed the employments, variable employment. Another one is I am keeping the stock also. Carrying cost is also there. No, varying employment involves what? Hiring and firing, and carrying cost will also be there. It means we have the inventory also. So I assume myself the number of employees we have being 40, 100 in the very beginning. I assume I recruit 20 employees higher here. As the production reduced, I fire 40 employees, so I make only 80, thereafter 100. This is purely assumption. You can assume your own, no problem. Okay. I assumed for the second quarter I recruited 20 employees higher as the demand is higher. Third, I just lay off around 40 employees. The fourth, I again brought back the employees to 100. Now come on, what about the production? 100 units means per employee can produce around 40 units per quarter. 100 employees 4,000, 4,800. 80 means 3,200 units. Here 4,000 units. What about the closing stock we have? Closing stock is nothing but opening stock plus production minus demand. Opening stock in this case being 1,000. With that, the production 4,000 is added. 5,000 minus 3,500, 1,500 we have the stock. 4,800 plus 1,500 minus 5,000. Now what happens? 1,300 will be the closing stock. Here 4,500 minus 4,000, 500 being stock. Finally 4,500 minus this one, 1,050 will be the stock we have. Okay, you can assume your own different strategies you can follow. This is called mixed strategy. This is purely assumed. Can I assume the additional employees being 110 and here 90? Of course you can do so, no problem. This is my assumption. Okay. Now what happens here? Sir, can we assume differently, sir? Yes, you can assume. As per your assumption, the solution what we have given may be the correct one. may not be optimum. Why it is not optimum? Because there are n number of other models also possible. As we have n number of other models, then we have the different answers. Even hundreds of models or hundreds of solutions may be possible. So what happens the examination, sir? We don't get confident to come out from the examination with our own assumed answer, sir. No problem. In your examination, most probably they may restrict one or two models only. That's how the question may be drafted. So next illustration will understand that one also. No problem. Now, here, how many employees are hired? 20, 20. How many employees are laid off? So from here 20 employees hired, from here 20 employees hired. From here how many employees are fired? 40 employees. So overall stock you have here being 34,800 units, sorry, 4,350. Here 40 employees are hired over the 4 quarters and 40 employees are fired. Now find out the cost. For stock holding, carrying cost 4,350 into per stock per quarter cost is 8 rupees. Come on, find out the full value. 34,800. For hire cost, 40 employees hired. For every time we have to spend for hiring one employee 16,000. For layoff, how many employees are laid off? 40. For laying off of every employee, it costs me 600, 24,000. Overall cost for the suggested model is 74,800. This one is purely assumption. If you assume otherwise, then the answer may be totally different. Now let's move on to the next question, 7 and 8. I finish off 7 and 8 by today. So with that, aggregate planning is over. After the aggregate planning, material requirement planning, manufacturing resource planning, economic batch quantity. These 3 chapters will be taught after costing paper. In costing, I'll start with the material costing and batch costing parallelly for the CMA Group 1, CA Group 2. With that, you have to attend these topics also. These 2 topics are similar to FM, material management. Okay, inventory management we have not studied, right? In financial management, we have inventory management, right? So with that, we complete along with that topic, right? Okay. So now it is not a big deal to be covered here. After completion of these two questions, I will go for um, pattern CPM. Pattern CPM. Okay. Project management, sixth chapter. Okay. I think for that I need one full 3 hour session or 2 2 hour session I may need. Okay. Sixth chapter. Let's start with question number 7. Come on, join with me to solve this illustration. It's pretty simple. The order position, that is requirement of dispatch for the next 12 month details. Requirement is in units, thousands, in thousands. Okay, month 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 months. And requirement being, demand being 13,000, 12,000, 10,000, 9,000, 11, 13,000, 11,000, 7,000, 5,000, sorry, 15,000, 13,000, 12,000, 10,000. The production capacity of the shop being 10,000. What is the capacity? You are capable of producing 10,000 units every quarter, every month. Okay. Clear? On regular basis, and 3,000 units per month on overtime basis. You can depend on overtime also. Using overtime, you can produce another 3,000 units. Subcontract can be relied upon up to another 3,000 units per month. Okay, but once you plan to go for subcontract, you have to give the lead time of 3 months. You have to order 3 months ahead. Lead time means you have to order ahead. Wait for 3 months to get it delivered. Cost data reveal as under. Regular basis, you can produce 10,000 units, and overtime basis 3,000 units. Subcontract 3,000 units can be produced. The cheapest one is regular basis. So you have to choose the first option being regular basis. If you don't have the options of producing or the shortage is there, then you can depend on second option being subcontracting. Even if you are not able to produce using the subcontract, then we don't have the options. We have to go for the last options overtime, which is the third option. Assuming that the initial inventory being 1,000 units, already we have opening stock of 1,000 units, and the stock holding cost being 1 unit per month, and that no backlogging of orders is permissible. You cannot supply delay. Okay, suggest an optimal production schedule, right? So we produced all these things, right? Now what you have to do? You can go for the overtime or subcontract. Subcontract delivered. Initially you are in need of 13,000 units, but you are capable of producing only 10,000. Already you have 1,000 units as opening stock, 2,000 units in shortage. 2,000 units in shortage. Now tell me, can you go for overtime or subcontract? Overtime costs me 9 rupees per unit. Subcontract means it's only 7 rupees. For the 2,000, can I go for overtime or subcontract? Okay, overtime or subcontract? I had to go for overtime only, though it may be costliest one, 9 rupees. Subcontract is 7 rupees. Overtime costliest one. Okay, costliest one, 2 rupees. If you go for subcontract, it may be only 7 rupees, because overtime I have to spend 9 rupees. Yet I go for overtime because in case of subcontract, I have to intimate 3 months ahead. I predicted today only. This day one only, I have predicted that the coming days demand may be 13. Stock 1 is manageable. Another 12 is met with the production where I am capable of producing only 10. 2 is shortage. Cannot rely on subcontract. I can go for the overtime. Okay, what about the stock? We don't have the stock. Initially we have 1. After this, we don't have stock. What happens the next month? 12, we don't have stock. We don't have stock. Isn't it? So our production capacity is 10, 2 shortage can be produced using the overtime. Third month, 10 demand, capacity is also 10, so we don't have the overtime requirement. Okay, 9 and 10 is produced, 1000 you produce excess, then you can keep this as a stock. Okay, this will be your stock. Next month, 11 is required, 10 is produced, already we have stock 1, you can use that stock, so we don't have stock thereafter. Sixth month, I am in need of 13 units to be supplied, but I can produce only 10. Shortage 3. What can we do? Huh? We can go for subcontract. Subcontract delivered here means at least 3 months ago, 1, 2, 3. Here I could have ordered. Okay. 1, 2, 3. Third month. This is subcontract ordered. You calculated that you are in need of 3000 units to be supplied in addition to your capacity by the 6th month end. Then 3 months ahead itself, if you order to the subcontract, then it may get delivered by the 6th month. Is that okay? By the 6th month. That's how we can plan. These two are implemented. These two are implemented. What about the 7th one? Again, I'm in need of 11, 10 is produced, then one can be subcontract, and as we have to deliver in subcontract by the 7th month end, 4th month itself I can order. 4th month itself I can order. Order and deliver. And 8th month, 7 is required, 10 is produced, then excess production can be kept as a stock. And 5th month, 15 is needed, 10 is produced, 10 plus 3, 13 we have. Because of the stock we can manage up to 13, but 2 is shortage, can be made available by subcontract delivered. If I want to get it delivered 3 months ahead, I have to order. Here I have to order this 3 months again. Okay. And 10th month, 13 is needed, 10 is manufactured, and 3 is shortage. This 3 can be ordered 3 months ahead with the subcontractor. He delivers this by this time. And 11th month, 12 and 10, 2 is shortage, 2 can be manufactured using the subcontract by intimating him 3 months earlier. And last, we don't have any additional requirement. So regular production 120 units, overtime production 4 units, subcontract production being, come on, 8, 9, 12 units, and we have stock 4 units. 4 units being stock. Stock holding cost being 1 rupee per unit per month. Now I have to calculate overall cost here. Based on this information, I can calculate the overall cost here. Yes. Production. What's the cost? 120 units produced, per unit costs me 5 rupees. 600 rupees. And overtime. How many units produced using overtime? 4000 units. Per unit requires 9 rupees. 36,000 I am in need for overtime. And subcontracting. 12 units are produced using the subcontractor. For that I have to spend 7 rupees, so 84,000 rupees. And carrying cost for the holding stock 4 units. For carrying 1 unit requires 1 rupee per month. So 4 into 1, 4 rupees will be the cost here. What is the overall cost under this mixed strategy? 7. 11 units. Okay, this one is 11 units. Okay. So 11 means 77. Overall value be 717. 717 will be the total cost. 717 will be the total cost. Clear? So in your examination, you don't have any other options. Only this option is possible as per the instruction given in the question. Last question also you have to guess, but here requires no guessing. Clearly stated in the question, this is the approach you are able to make, okay, without any deviation. Now we'll move on to the last illustration, question number 8 here. Question number 8. From the following forecast, determine the monthly inventory balance required to follow a plan of letting the inventory absorb all fluctuation in demand. So you have to maintain inventory sufficient enough to absorb all the demand in the future. In this case, it is assumed to have a constant workforce, no idle time or overtime, no back orders, no use of subcontractors, no capacity adjustments. Assume that the firm does not use safety stock or cushion inventory to meet the demand. So nothing is there. So only you need to maintain the inventory required for production, not more than that. So from this it is very clear for the 12 months, Jan, Feb, March, April, May, June, July, August, September, October, November, December. What about the demand forecasted? 220, 90, 210, 396, 616, 700, 378, 220, 200, 115, 95, 260. What is the total demand for these 12 months? Is it 3,500? Now, how many production days are there? Do the summation. I think 250 working days are there. So, production estimated per day 3,500 is the annual demand produced over 250 days. You have to produce 14 units per day. So you need to have the workforce capable of producing 14 units per day. 14 units per day. Okay. That remains unaltered. You don't change. Now come on, tell me what is your production. 14 units you are producing per day for 22 days. 308 units are produced. Then for 18 days 252 units are produced. Then for 21 294. Then for 22 308. Again 22 308. 20 280. 21 294. 22 already we have to 308 for 22 days. 20 280. 23 322. 19 days 266 and 20 280. Also matching. What you plan to produce is equal to the demand. Okay. Demand expected. So demand expected is produced over the period, but the number of working days in a month is totally uneven to the month after month. May not be same. Now come on, find out the stock. So in the very first period you produce 308, but demand is 220, 88 being stock. Next month 252 produce, 88 already stock is there. 90 is supplied, then 250 will be the stock. Okay, stock is equal to opening stock plus production minus supply or demand. 250 plus 294 minus 210, 334, and 334 plus 308 minus 396, 246. Then 246 plus 308 minus 616. 62 minus 280 plus minus 62 plus minus 700 minus 482. 294 minus 482 minus 378 minus 566. 308 minus 566 plus minus 566 minus 220. 478 minus 478. 280 minus 478 minus 200. 398. And 322 minus 398 minus 115 minus 191. 266 minus 191 minus 95 minus 20. The last becomes 0. But here what happens? You cannot have the safety stock, cushion inventory, you cannot do the capacity adjustment, no idle time, no overtime, and even though you have the negative stock, you cannot be allowed. Then what you can do? Already I told you, no, the maximum shortage in July 599 will be assumed to be the opening stock. Assume or hold the opening stock is equivalent to maximum stock out in the planning period. In the planning period. In the planning period. Opening stock. Maximum stock out in the planning period. Okay. Hold max opening stock. As you estimated, in July we will be facing the maximum stock out being 566 ahead today itself. So you plan to have the opening stock to that extent of 566 in the day one itself. Now adjusted stock. Come on, tell me. 88, already we have opening stock 566. 566. So 88 plus 566, 654. It means you have to add 566 with this one. 250 plus 566, 816. 334 plus 516, 566, 900. 246 plus 566, 812. Minus 82 plus 566, 504. 48. Which month? 654. Okay, 654. Okay. And here 482 minus 566, 84. Minus and plus, it becomes 0. Here you have 88. And here you have 168. Here you have 375. 546. 566. So under this model, the opening stock you assumed here, which is 566, becomes closing stock. This closing stock becomes the opening stock for the next period to be used. Okay. Hope now you will be able to understand. Clear? So with that, aggregate planning is completely over. Today we have completed two chapters in detail. One is layout, another one is aggregate planning. Location was already completed. One additional illustration covered here. Okay. That's all for today. We'll continue the rest in the next class.